Okay, so the pH scale. What is it and why do we care about it? So, pH stands for the power of hydrogen. So, when we talk about different solutions and we think about something, if it's considered like acidic or not, we're using this term pH and we're talking about that. And so, we're always going to be talking about the amount of hydrogens that are dissolved within that solution. And so we learned about hydrogen being an element on the periodic table. And when hydrogen has a plus sign with it, it's considered a hydrogen ion. So it's a positive hydrogen ion. And the different solutions that we consider acidic or basic or alkaline are going to either have a lot of hydrogen ions or a few hydrogen ions dissolved within it. So that's what determines whether something's acidic or alkaline. So as you can see on the scale here, if you have a pH of 0 to 6, it's considered acidic. And if it's a pH of exactly 7, it's considered neutral. And if it's greater than 7, 8 to 14, it's considered alkaline. So those things that are considered acidic have a very high concentration of hydrogen ions. If it has a very low concentration of hydrogen ions, then it's considered to be alkaline. So there's a lot of reasons why this is important. You'll learn a lot more about this when you get to chemistry, but at least wanted to introduce it now, especially when we're talking about foods and how our body is going to metabolize and digest those foods. So there are some characteristics of acids and bases. So the higher the concentration of hydrogen ions, like I said, makes it acidic. When acids dissolve in water, they're going to donate hydrogen to the water and create something called a hydronium ion. So you've learned about water being polar, so having partial positive, partial negative area. And so when it donates the hydrogen, it creates something called H3O plus, which is considered to be a hydronium ion. Acids also have a very sour taste. So things like lemons or limes are acids. And then they also can conduct electricity. Bases, on the other hand, have a much lower concentration of hydrogen ions because they have a high concentration of hydroxide ions. So basically, when acids or bases mix with water, they're going to separate the water molecules to become a solution. So they're interacting with those oxygens and those hydrogens. And so since there's a lower concentration of H pluses or hydrogen ions, they're going to be separating the hydrogens away and pulling them towards the acid. There's going to be more hydroxide ions. And they have a very slippery feeling and have a bitter taste. So think about if you ever get shampoo in your mouth, it tastes really bitter and gross. And then those also conduct electricity. So you can go ahead and pause if you need to and record these on your notes as well. So why do we care about learning about pH? So it's important, especially when we start talking about nutrition and how our body digests different things, because our intestinal tract digestive system has different pHs throughout. So our mouth is very neutral because of the saliva. And then as we go into the stomach is very acidic. It has like a pH of 1, which is extremely acidic. And then as you go into the intestines, it becomes more neutral, maybe slightly acidic. And so that is what alters the way our body can actually digest food. So that's one application of this. Also, it's just important to note that knowing pHs of substances allows us to better know what we can digest, what types of food that we can eat, and also just kind of health side effects if we are eating certain foods that are making us sick versus not. And so I'd like you to write a few of these examples down of some kind of common substances and their pH in your notes. It gives you an opportunity to write the name of the compound, pH, and whether it's acidic or basic. So on this scale, you can see it is split up into very acidic, acidic, slightly acidic, neutral, slightly alkaline, alkaline, and very alkaline. So Hydrochloric acid is very, very acidic. As I said, that's like what's in our stomach is hydrochloric acid, so it's a pH of 1. Coca-Cola is actually a pH of 3, and it actually can take rust off of nails. So when you're drinking Coke, it's pretty bad for you. Um, you can see mineral water that you're drinking is not necessarily neutral. It's a little bit acidic. pH of our blood is about 7.76, so neutral. And soap is alkaline, laundry detergent, and then lye, which is sodium hydroxide, which is what they used to use as soap back in like the Wild West, and they thought that that would get our skin clean. Well, it's actually very, very basic and was very harmful to our skin. So then go ahead and you can go back, and if you need to fill in any of your notes that you missed, but you can turn in their notes onto Canvas.